So in looking at matter, there's so much different types of matter out there that we need some way of describing those different types of matter. So we've come up with a very basic system. If we look at matter, and if we know that that matter is a pure material, in other words, it doesn't vary at all, we'd call it a pure substance. And then from that pure substance, we could either have an element, and keep in mind those elements could be in the form of atoms or molecules, or if that pure substance is a combination of elements, it's going to be considered a compound. Now, if that matter itself isn't pure throughout, or it has a variable composition, it's going to be something we called a mixture. In other words, it contains multiple elements, multiple compounds. It's those mixtures we talked about. Now, if that mixture is not uniform throughout, something we call a heterogeneous mixture. So, for example, wet sand, if we pick up wet sand, put it in a beaker, you'll probably have some sand settled at the bottom, may have some water in there. It's not uniform throughout. If the mixture is uniform throughout, it's something we call a homogeneous mixture. So, example we have here, if we take tea and dissolve sugar in it, no matter where you take a sample or a taste of that tea from, it's going to taste the same. It's going to have the same composition if it's a homogeneous mixture. All right, so it's going to be important that we understand this distinction between mixtures and compounds. Let's go through it just one more time to make sure we got it. So with a mixture is going to contain more than one type of a compound or an element. If that mixture is heterogeneous, it's going to have a varying composition throughout. So depending upon where you sample that mixture from, you could get a different composition. You could also have a homogeneous mixture, which has a uniform composition throughout. Now, when we talk about homogeneous mixtures, a lot of times people call these solutions. And keep in mind, a solution doesn't have to involve a solid dissolving in a liquid. It could be a liquid dissolving in a liquid. It could be a gas dissolving in a liquid. It could be a gas dissolving in a solid. It could be a solid dissolving in a solid. An example of a solid dissolving in a solid would be an alloy, where you take two metals, you melt them down, and then you mix them together. And when they re-solidify, they form this alloy. But it's really just one solid dissolved in another. Now, an important distinction we need to make, because this is going to be very, very important when we hit Chapter 4 and we start talking about these types of solutions. Something called an aqueous solution. Whenever you see aqueous, that's referring to being dissolved in water. So an aqueous solution is something that's being dissolved in water. So solutions is a more general descriptor, dealing with a lot of different things that we could have. An aqueous solution is specifically water is a solvent, we're dissolving something in water. Okay, we could also have pure substances. Remember, pure substances are going to contain only one type of compound or element. So we could have elements. Remember, those elements could be in the form of just atoms, could be in the form of molecules. We could have our compounds, our pure substances. Those are only going to exist as molecules. And just to go through the pictures again, so an element can exist as atoms. There's pictures of those single atoms of an element. An element could exist as a molecule, which is two or more atoms of the same element combined together. We could also have a compound, which is atoms of two or more different elements combined together. And then we could have our mixture, which is a combination of more than one element or compound mixed together. So let's look at some examples of this. So what we're going to do here is, you're going to take a moment, look through these, decide whether you think it's an element, a compound, a heterogeneous mixture, or a homogeneous mixture. And if you want, you can refer back to that little flow chart that helped kind of break matter up into these different things. Take a moment, pause the video, write your answers down, and then compare your answers to the answers I'm going to go through right now. Alright, so let's look at gasoline. Gasoline should be a homogeneous mixture. Now there's a lot of things in there, there's a lot of different chemicals and compounds, but when you look at gasoline, it's uniform throughout. What about water? Water is a little bit of a tricky one. When I say water, I'm talking about pure water. Pure water is going to be a compound, H2O, that's pure water. Now if you look at tap water has different things dissolved in that water, so it would be more like a homogeneous mixture. Alright, so let's look at iron metal. What would that be? Well, that would be an element. That one's pretty straightforward. What about brass? Brass is actually going to be a homogeneous mixture. Brass is actually a combination of copper and zinc, but it's not that the copper and zinc are reacting with each other. We just take some copper, melt it down, some zinc, melt it down, take those two liquids, mix them together, and then let it re-solidify, and that's how we're getting the brass. So that's a homogeneous mixture. What about air? Well, air, similar to water, depending upon what you're talking about, could be a heterogeneous mixture. Air inside your, let's say, house, that air is going to vary in composition. So it's not a uniform mixture. But if we consider air, let's say, inside an air tank that scuba divers use, that would be a homogeneous mixture. It's a mixture of gases that's uniform throughout. All right, what about seawater? Well, seawater could be a heterogeneous mixture. If you just go scoop up some seawater, you may end up with particulate matter. If you go out to the ocean, you may end up with seaweed in it. So it's not uniform throughout. Could be a homogeneous mixture, though, if you're just talking about, in general, seawater. That's really just salt water. And salt dissolved in water is going to give you a uniform mixture. What about sand? Well, if we look at sand, sand is actually a compound, silicon oxide. So it's actually a pure substance if you have pure sand. If you go out to the beach, though, and just scoop up some sand, chances are you're going to get a heterogeneous mixture because it may have seashells in it, it may have little bits and pieces in it, may have different things inside of it, if we consider that as sand. Those are all examples of ways we can classify matter. And lastly, we want to look at how we're going to separate mixtures. And this is something that would be dealt with more in the lab. When we look at a mixture, each component in that mixture is going to still keep its own properties. Okay, that's very important when dealing with a mixture. We're not talking about things changing from one thing to another. It's not going through a chemical change. We're just mixing things together. That's a physical process. Because they retain all their own properties, we can use these properties to actually separate out these substances. For example, mixture of iron filings in cereal. Well, if you look at iron fortified cereal, the way they fortify it with iron is they throw in small pieces of iron into the cereal. Your body can break down the iron once it gets in your stomach acids to break it down in a usable form, but when we look at this, it's actually iron mixed with the cereal. So we can use a physical property to separate those two. We can actually use a magnet, and if we get a strong enough magnet, to actually separate out the iron filings from the cereal. That's an example of using a physical property to do a separation. Now, if we look at a mixture of iron and gold filings, we can actually use a chemical property to separate those two. If we put that mixture in some concentrated acid, the iron is going to dissolve, but the gold won't. So we can actually dissolve the iron and then filter out the gold from that solution that we made. That would be an example of using a chemical property to do a separation. So when looking at separating out mixtures, there's a wide variety of things you can use. And there's a wide variety of things that you're already familiar with. You know, if you've made coffee, you use coffee filters. That's separating out the solid coffee particulate matter that's left over from the coffee you made, the stuff you want to drink, from the liquid. Okay, so that's what we're going to be dealing with when we're going to be talking about classification of matter.